Hi everyone, in this video I would like to talk about evaluating parts before you actually buy them. Initially in our team, what we wanted to use for a season was a pair of mechanum wheels from AndyMark, and as you might know, those wheels are extremely expensive. So we ended up needing a way of checking if we actually buy those wheels, if we will be able to use them. And as you might know, a lot of different companies that sell parts online have a service where they release CAD parts so that it's easy for people to check if they want or need to use those parts before you actually buy them. And we're right now on AndyMark's homepage. We're trying to find a 6-inch wheel model and download the CAD files for those. And since we don't really care about the left and the right different formations in this case, because we're just trying to see if the wheels would fit, if there is a way to make the TETRIX parts fit with these wheels, we are going to just download left or right. It really doesn't matter, one of the two. And as we're waiting, we will have to go and try to find the conversion plate that makes these wheels fit the hole sizes and patterns for TETRIX. Let's dig around the AndyMark homepage for some time. It might be a good idea to go and check the wheels page. Not here. Where are those conversion plates? Well, here they are. So now we found those. Let's download the files and import those. Import the two files that we just downloaded into SolidWorks parts. Click yes for import diagnostics, but you don't really need feature recognition at this point. To make it look like all the other parts that we use, let's look at that in a different display mode. Just to make it look like one of the things that they're actually selling, let's set the part to be in 6061 aluminum, which is actually what it is made out of. Let's save this as a different file. And then after we save this, we can go on to import the mechanum wheels into this for review. The mechanum wheel is probably made out of a lot of different parts. The step file is probably an assembly file. It is very difficult for the computer computationally to make sense of all those different features, so we're not going to do feature recognition again in this point. But then all the important parts, where for example where the holes are already defined perfectly, so there is, honestly speaking, no real need for us to do feature recognition. Since we're going to be putting this on a TETRIX channel, let's just get a random TETRIX channel for now. And what we want to do is to see if there's a method of using TETRIX parts and to fasten the AndyMark wheels onto a TETRIX channel. And we know that the big circles at the center for the wheels and also the conversion plate have to be aligned with the big holes at the center of the TETRIX channels. So let's go ahead and insert concentric mates. And now the concentric mates are done, we can go ahead and insert the axles. So we'll insert a D-shaft axle first, give it concentric mating, and then after that what we can try is to fasten the end of the axle onto the channel first. In order to do that, we'll be needing bearings and also collar set shafts. And as you can see, the concentric mating makes it look as if they're already connected by an axle. Since this is going to be a lot of different mating, let's use the mating menu. Rotate it a little bit that size so that when we mate, it goes in the orientation that we want it to go into. It's a lot of clicking. And then after setting the concentric mates, let's go on to add the coincidence so that they are nicely in a line connected together. It seems that the set color didn't go in right. Let's make a copy and get rid of that, and then start a new and use the new part to finish up the concentric mating. Set those two planes to be coincident, and since we want to use the maximum length of the shaft, let's make the end fit. To make the other side for the channel with the axle linear, let's add another bronze bushing. Now what we need to do is to find a way to put that wheel securely onto the axle. Before anything, we would know that that conversion plate would go onto that edge of the wheel, that edge of the mechanum wheel. So let's do that first by setting some mates. And as you know, the hole pattern at the center of the conversion plate is equal to the hole patterns in TETRIX kits, which means that it's possible for us to just use many of the parts used for mating axles and sprockets and chains, etc., with the FTC conversion plate. And if we don't want to make anything, like if all we just want to do is fit the wheel onto the axle, this is what we could have done. We could just put another bronze bushing over there and then somehow end that place with a collar. However, what we want to do is we want to use these wheels for driving. And in order to do that, we need to have sprockets at the side. Sprockets are gears, but then usually people use sprockets for drive chains. So we need to put a sprocket at the side of that FTC conversion kit, which may make things a little bit more complicated. So when we're adding a sprocket, we could just do this. We could make these sides coincident and just bolt it in. It may not seem like a problem until you look at it on this side. If you look at it this side, it shows that if you put in your sprocket like that, it's probably very likely for the chains to get stuck onto the wheel because chains have width. And what this shows is if we are to put a sprocket, there has to be something else in between the FTC conversion plate and the sprocket. And to put something else in there, let's get rid of the mate, the coincident mate between the two parts. And I have a feeling that an axle shaft would be a perfect fit here because it has tapped holes, it's a good spacer, and also usually axles get through. Just the point, if you want to use the axles as something like this, it is advisable to get a drill that's around the similar size as the axle, and then drill a hole through the center hole so that you can use it as an axle holder, but also when you need it to, the axle can just rotate freely inside the axle holder. Anyways, let's try finishing up the assembly. Yes, like this. And as you can see, it's probably likely that the chains are not going to hit the wheels at the side. And to give adequate spacing between the TETRIX channel and the wheel, let's just for now put in one of these nylon spacers. And as we do, something might be crossing your mind. In order to keep the sprocket in that place, it needs to be secured with a bolt. But then the bolt might actually coincide with the nylon shaft. I mean, the nylon spacers. And since we're trying to check if an assembly is possible or not in this case, it's actually beneficial to finish up an assembly complete with bolts and nuts and everything. Let's pull that out a little so that it's easier to select the planes for coincidence. And right here we can do an interference check to see if there are any interferences between these two. Let's go ahead to the evaluate menu and check for any interferences. Remember, there may be other interferences in this case. However, all that we honestly care about right now is if there are any interferences in between that bolt and the nylon spacer, because we know that other places will fit. And here you can see that there is a very slight overlap in between these two parts, but an overlap this small can be usually solved by sanding off the bolt or the nylon spacer. So honestly, we can assume this is not a big problem and then just go on to finishing up the assembly so that we can be sure we can use these wheels, and then go ahead and order them. Let's put the bolts all around. So we should be using copying with mates, because we're basically putting in the same bolt in the same place with the same definition of mates. And now most of what you have to care about right now is sticking that wheel at the edge. And as you might know, wheels usually have to take up a lot of weight, and these parts are really awesome for making the axles more durable and to make the wheels turn smoother than just using conventional bronze bearings. So let's put this spacer at the edge. But again, something that we may have to wonder is what keeps this axle spacer over here. It's a pair of bolts, but then those bolts go into the axle holder that is on the other side, which means that we can't have 4 bolts in this side. We can't have 4 bolts on the sprocket side. We have to use only 2 and then leave the other 2 to be used with the axle holder. No, not the axle holder, the spacer. Let's go ahead and add these screws in here. Make sure that they are on the other side so that the assembly of this, if you actually end up buying these wheels, will become much easier. Finish up the mates, and then after that we can do copy with mates so that the assembly would look complete. And after finishing this part, if we just add a small spacer and then an axle collar shaft, this assembly would be pretty much over. There may be better ways of fixing this wheel onto the base, of which we'll be looking at very soon after this demo is done. But this is pretty much all we can know about the fact that through this we can find out using AndyMark mechanum wheels are not a stretch. And before a very big purchase, if just in case, if we order this, we get it, but then it turns out there's no real good way to fix it onto our robot, then that's a waste of money. And I honestly believe that there are not a lot of teams that can afford to use $200, $300 and then not get anything out of it. So this assembly is mostly finished, as you can see. And it seems that it is very possible to use these AndyMark mechanum wheels in a TETRIX setting by using their FTC conversion kit. In one of the later demos, in one of the later videos, I'm going to talk about using custom axles and designing sheet metal parts so that it is much easier and actually even smoother to control these wheels and to connect them onto TETRIX. But then for now, let's say it's enough for us to know that these wheels are totally fit for use with our TETRIX kits. And I remember these wheels to be around $250, but then yes, anyways, these wheels are really expensive, so the capability of checking out if they are a viable means of a viable part to use on a TETRIX based robot is very important. So I'm going to try to show you something that I actually finished before I ordered these wheels. It's a very simple sample base. It's a very simple sample base where I experimented with these wheels and tried to find out one of the strongest and the smoothest ways of connecting these wheels onto a TETRIX based setting. So yes, that's the base that I made. I guess some parts got changed, suppressed while missing parts, and you have this. It still looks a little different. I'm using like Garland bearings, for example, but then you can see that even in this case, using TETRIX is very, very possible, and the connection looks very sturdy. And only after making this, I was assured enough that I could order these 4 wheels and not get hunted down by our teammates for buying something that was absolutely useless. So this nearly concludes the video for today. Something that I have shown you guys today is how we can download different parts and experiment with them on SolidWorks as if we are making it on our own with the parts in our hands. And by doing this, it'll make it much easier for us to figure out how to put the parts when we're actually making the robot in the final place. Thank you for today, and see you in the next video.